Okay, so really quickly, a couple things that I wanted to cover is in your notes we talked about diatomic molecules. To remember these are the elements that occur as diatomic molecules in nature. So hydrogen, oxygen, nitrogen, chlorine, fluorine, iodine, bromine. Pronounce that Hunkelfibber. Hunkelfibber. So I know it's goofy, but it's a little mnemonic device that will help you remember those for your test. When we're looking at our Lewis dot structures and we're trying to figure out the structure or Lewis dot structure, what I'm going to do is I'm going to first write all the atoms that are involved, and I'm going to include their valence electrons. And so I'm going to draw the Lewis dot structure for each atom here. So my oxygen here has 6 valence. I got 1, 2, 3, 4, 5, 6. What I can see is I've got 2 pairs of electrons and then 2 lone electrons. So my 2 lone electrons are going to be the ones that are going to bond with my hydrogens. So I'll draw my hydrogens now. So then my hydrogen, both hydrogens just have 1 electron. So remembering that hydrogen, since it's in the first period, it just needs 2 electrons in order to be stable. Oxygen needs 8. So when these react and they form covalent bonds, so in this case, this hydrogen is sharing its electron with oxygen, and it's getting to share oxygen's electron here. So right here, they're forming a single covalent bond because both of these atoms are sharing these electrons. And so what I can do is I can use a line to represent that covalent bond. Okay, same thing with this hydrogen. This hydrogen is sharing its electron with oxygen, and oxygen is sharing this electron with our hydrogen here. So they're forming a single covalent bond here. And so I can use a line to represent that covalent bond. So we're going to do the same thing for methane. Here methane is CH4. So I've already drawn my carbon with its 4 valence electrons. I just need to draw my hydrogens now. So now we see that our hydrogens have moved in. Again, we're now sharing these 2 electrons between both of these atoms, these 2 between these 2, so on and so forth. So if we look at how many electrons that carbon has here, how many valence electrons we have, we've got 1, 2, 3, 4, 5, 6, 7, 8. So 4 of those are coming from carbon itself, and 4 of them are coming from these hydrogens that are covalently bonded to our carbon. With our hydrogen only needs 2 valence electrons to be stable, and each of these hydrogens now have 2 valence electrons. So I can represent each of those single covalent bonds with a line, and that tells me that we're sharing 2 electrons between these atoms here. So what I want you guys to do on a piece of paper, I want you to draw the Lewis dot structures for both hydrogen fluoride and hydrogen chloride or hydrochloric acid. Okay, the last thing I wanted to talk about is just kind of clearing up, let me fix this, the difference between the representative units of our molecular compounds and our ionic compounds. Our representative units for our molecular compounds are molecules, and so what this is we actually have a discrete unit or a discrete particle that we can look to in our molecular compound is made up of a bunch of these little particles. And so with our molecule, what we see is that the atoms in this molecule and this particular molecule are only bonded to each other. They are not bonded to these other molecules that make up that molecular compound. Whereas with our ionic compound, we don't have that discrete unit. So our representative unit is what we call a formula unit. And all that is just a ratio of anion or cations to anions. Because when looking at this anion is ionically bonded to this cation, which is ionically bonded to this anion, and each of these are bonded to each other. All right, so we have all these ionic bonds between all of these different ions, and there's no one particular particle that I can take out and say that's a representative unit, that's a discrete particle that makes up this ionic compound. So instead we say that the representative unit is a formula unit, and that formula unit is a ratio of cations to anions. So in this case, if my red circles represent my cations and my black circles represent my anions, what I have here is I have 1 red to every 1 black. So the way I would write this formula unit is RB. So this would be like an ionic compound similar to sodium chloride, where sodium is my cation, chlorine is my anion, and we have, for every 1 sodium, I have 1 chlorine. And now if I had, for every 1 red circle, I had twice as many black circles. The way I would write this as a formula unit, I would write RB2. And that 2 just represents that there are 2 black for every 1 red. So this would be like an ionic compound such as magnesium chloride, where for every 1 magnesium, I have 2 chlorine atoms, and that's because magnesium has a +2 charge and chlorine only has a -1. So in order to cancel these 2 charges out, my chlorine, I need to have twice as many chlorine atoms as I do, or chloride ions as I do magnesium ions. So hopefully that kind of clears that up with representative units. For our molecular, we have representative particles called molecules, and for our ionic, we have formula units because we can't pick out individual particles from my ionic compound.